Good day, my name is Timothy Adekunle. Today I would like to talk about relationship between probability mass function PMF, probability density function PDF, and cumulative distribution functions CDF. Probability distribution. Definition. A probability distribution is a statistical function that describes all the possible values and likelihood that a random variable can take within a given range. Probability mass function PMF for discrete random variable. The probability mass function PMF is a function that gives the probability that a discrete random variable is exactly equal to a specific value. It is only used for discrete random variable. PMF is denoted by f into bracket x. PMF formula is f into bracket x equal to p into bracket capital letter X equal to x. Probability mass function properties. Let S be a discrete random variable with mass function f of x. Then the probability mass function should satisfy the following conditions. 1. P into bracket x equal to f into bracket x greater than or equal to 0. 2. Summation of f of x equal to 1. Probability density function PDF for continuous random variable. The probability density function PDF produces the likelihood of values of the continuous random variable. It is also used to define the random variable's probability coming within a different range of values opposed to taking on any one value. PDF formula. For any constant a, b is p into bracket a less than x less than b equal to integral of b to a f of s ds, or p to bracket a less than or equal to x less than or equal to b equal to integral of b to a f of s dx. That means for any constant a and b, p into bracket a less than or equal to x less than or equal to b is equal to p into bracket a less than x less than or equal to b equal to p a less than or equal to x less than b equal to p into bracket a less than x less than b. Probability density function properties. Let S be the continuous random variable with density function f of x, and the probability density function should satisfy the following condition. Number 1, f of x equal to integral b to a f of s dx. 2, f of x greater than or equal to 0 for all x. And 3, integral infinity to negative integrity f of x ds equal to 1. The difference between PMF and PDF. PMF, solution ranges between numbers of discrete random variables, while under PDF, the solution is in a range of continuous random variables. 2. Uses discrete random variable, while PDF uses continuous random variable. Cumulative distribution function CDF. Cumulative distribution function CDF of a real valued random variable x evaluated at x is the probability function that x will take a value less than or equal to x. CDF is denoted by capital letter F into bracket x. CDF for a discrete random variable is capital letter F into bracket x equal to p to bracket capital letter x less than or equal to x. CDF for a continuous random variable is integral ranging from x to negative infinity f of x to bracket t dt. Cumulative distribution function properties. The first one says every CDF is not decreasing and right continuous. The second one says for all real numbers a, And B. The cumulative distribution function can be obtained by integrating the probability density function. And the third one says summation of probability density function equal to cumulative distribution function for discrete random variable. Relationship between PDF and CDF for a continuous random variable. Let S be a continuous random variable with PDF, F and CDF, capital letter F. Then, number one relationship, the CDF, capital letter F, can be obtained by integrating the PDF, small letter F. Number two relationship, the PDF can be obtained by differentiating the CDF, capital letter F. Conversion of PDF to CDF and vice versa. Example, let random variable S be the amount of time needed by students in a particular course to complete an hour test is a random variable with PDF given by f of x equal to k into bracket x raised to the power 2 plus x if is 0 less than equal to x less than equal to 1, 0 otherwise. Question 1. Find the value k that makes f of s a PDF. Find the CDF. Use the CDF to find the PDF back. As we know that cumulative distribution function is the integration of probability density function. And when we integrate probability density function, we are going to obtain 1. And the given probability density function is equal to k into bracket s squared plus x. At the time we integrate the probability density function, we obtain this. So we now put the limit of integration, which is 1 to 0, into the equation 3. We obtain this. And after that, you can see that the value of k is 6 over 5. So to obtain the cumulative distribution function, capital letter F into bracket x can be obtained by integrating small letter f into bracket small letter s from negative infinity to an arbitrary value x. If x is in the interval negative infinity to 0, our cumulative distribution function equal to this. And we know that our probability density function is equal to 6 over 5 into bracket s raised to the power 3 plus x. So when we integrate this probability density function, we obtain this. And we put the limit into the equation 3. We obtain this. We can see that when s falls into the range of negative infinity to 0, our cumulative distribution function is equal to 0. To calculate for when x is in the range of 0 to 1, then we write our formula as this first equation. So we put our probability density function into the appropriate place. We obtain this. And when we integrate, we obtain the equation 3. And after the equation 3, we put our limit into the equation 3, we obtain the equation 4. And when we do the calculation, we see that our f of x equal to 6 over 5 into the bracket s raised to the power 3 divided by 3 plus s raised to the power 2 divided by 2. And the last one to consider is if x is in the range of 1, infinity, then we have this equation 1. But we should note that in this range we have 1 to infinity. That is to say, this range has been exceed our given limit in the equation. So therefore, the last integral will automatically be 0 because our limit has been exceeded. And we have already known that the first one here is 0 by the previous calculation. Now, when we compute the middle one, we have this, and which equal to 6 divided by 5 into the bracket 5 divided by 6. So therefore, when we compute for the limit 1 into infinity, we see that f of x equal to 1. So therefore, this is our CDF. And the first one is when x is less than 0, we have a 0. When s is in the given range, we have 6 over 5 into the bracket s raised to the power 3 divided by 3 plus x raised to power 2 divided by 2. And when x is greater than 1, which is the upper limit of given limit, we have 1. To obtain our probability density function back from the cumulative distribution function, we use the formula by differentiate the cumulative distribution function. When we differentiate it 0 plus the middle one, which is 6 over 5 into the bracket x raised to power 3 divided by 3 plus x raised to power 2 divided by 2. Now have plus, we differentiate 1 also. And when we differentiate 0, it gives us 0. When we differentiate the middle one, we have this. And when we differentiate the 1, we have 0 because they are constant. And that we can see that we obtain our given probability density function back. Next time, I will discuss the practical application of both PDF and CDF in detail. Thank you. Don't forget to subscribe to my channel. See you next time.